I think that you could say that gambling is to the blockchain as porn is to the internet. We're not going to be able to get rid of it. It is here to stay in one way or another. But I'd also like to defend gambling in the context of games, just a slight chance, and not gambling, but really random number generators. Here is a picture of backgammon being played by a super AI. And backgammon is a game that involves chance. So even though it's one of the longest, oldest, greatest games that have been around, it still remains that the world's worst backgammon player has a chance of beating the world's best backgammon player just because there is a destabilizing aspect of chance. And so when it comes to these adversarial environments in which games are on-chain, having random number generators is one of the only surefire ways to destabilize the bot versus human dichotomy. I want to mention this term autonomous worlds. So it's come up a lot this year, especially there was a DevConnect conference in Istanbul around it. And autonomous worlds is this idea that you can build a game which persists to the point that people can live inside of it, that they can build their own things, that it goes on beyond any one single person. And that's a really exciting concept. But that concept's been around since the first days of blockchain. And why has autonomous worlds suddenly sort of picked up steam in this new banner? And I think really what it is just it's a commitment, a recommitment to stop making bad games. It's remembering what actually is exciting about this and not going straight down the path of trying to make money as fast as possible with games and really just reducing the level of fun or play. Which brings me to the question, why are on-chain games bad? And of course, there's bad UX. There's the problem with keys, with gas. The on-ramp and the off-ramp still exists. But there's also this problem of bad users. And I don't blame the users for this. I blame the game creators for creating bad users because they equate farmers with players, speculators with players. This idea that they're creating a game which looks like a game enough to justify raising money around it. And then you have a player group which is invested in the game being seen as a game, pretending basically to be players. It's this sort of bizarre zombie theater happening. And so you don't really need a core loop. What you need is sort of a semblance of a core loop. And so at the end of the day, you never really have to make something fun because you're all just sort of pretending that it exists as a game. It's legitimate enough to continue that loop. But there's also very real problems with the limitations. And that's what the rest of this talk is about. Stuff around limited computation, prevents your expressivity, and limitations on the speed. So today, there are a number of on-chain games, and most of them are written in this left-hand side, this grid-based movement. It's essentially a board game which is written as code and run on a blockchain because of the limits of expressivity and speed. What I would really love to see, and what I'm proposing here, is a small phase change just to the right side of the screen. Super Mario is extremely a simple game in terms of software programming, except for it's just a huge phase shift of expressivity, fun, and speed compared to these turn-based, slow, board game-like games. And board games are fun. I don't mean to bash them, but why limit ourselves to that category of games? So what's the sort of state of things right now? We have one camp, which is kind of the MUD v2 by Lattice. This is a Solidity framework. And their mentality is basically gas be damned. We just need more sophisticated frameworks to be able to write more complicated applications. Yes, it'll be more gas heavy, but gas is going down eventually. Eventually, it'll be fine. But this is still limited by the block time. You're able to push down block speed to 2 seconds, 1 second, but that's still a huge lag inside of any sort of game expression. The category that I'm much more excited about can be described as Validium games. And on one side, you have ZK VMs. So this is where your entire virtual machine that runs your game is proven with a zero-knowledge circuit. But that's extremely slow and expensive because every single operation has to be proven. And the time it takes to generate those is really long. So the one that I'm much happier with is the hard ABAFAIR direction using handwritten circuits. And my favorite language for that is CIRCOM. And what basically happens here is that you play first and you verify after. So this is the Validium game or ZK rollup game idea. And if you're not familiar with ZK snarks in general, the way a Validium game would look and does look is you have things like public inputs. This is an input that everybody sees. This can essentially be the initial game state. And then you have private input. And these are the user input. You can think of this as kind of a key logger. Every stroke, every key, every action that a user does becomes a private input. Inside the snark, you have remodeled the entire logic of the entire game. That is run through, and what comes out is the public output, which is the final game state, the speed, the score, whatever you may have, plus a proof that says, yes, this is a legitimate outcome played on this actual game modeled in this ZK snark. I like to use this example from Radical Software Group, an artist collective in the 2000s, who put a keylogger onto a Nintendo Entertainment System controller, and they recorded every single keystroke somebody playing and beating the entire Super Mario Brothers game. They then took this entire output, put it in guitar tabulature form. As you can see down here, you have left, right, up, down, B, and A, and then printed the entire thing inside of a hardcover book about this big. So this is a completely useless object, but you can see that actually if somebody had taken that, plugged it back into Super Mario Brothers, they could replay the entire thing and they would be guaranteed the win because the system is deterministic. And so as long as it's deterministic, you can replay the entire thing and get the same result. So this is what I'm proposing with the ZK system. You have two lines of logic, basically. One is in the snark, which verifies the game, it has all the core game logic. And the other one is in any sort of game platform that you'd like. So you're no longer restricted in any sort of way. So pick your platform, make it work. Make sure that your game logic is one-to-one equivalent from your snark and in your game engine. And at the very end, you'll have the same output, and you can verify that. So just quickly mentioning that Circom is my favorite circuit language right now. It's used in production. It's probably the most used circuit language in production, including by Tornado Cache. It's kind of almost a scripting language. It has a nice balance between like the actual math that represents the ZK stuff and like scripting-like code. It's faster and cheaper than ZKVMs. Blockchain devs love to suffer, of course, so why not? Comes with a solidity verifier, and it really makes sort of for maximum sovereignty because you can target any EVM, you can bring it around. It has so many supported environments that it allows you to sort of not be restricted to a single place. But you might be wondering, don't all of these sort of point to single-player games? And that is true. And single-player games are no fun, right? Well, dubious statistic here is from World of Warcraft, which I think you probably all would think of as a really popular multiplayer game. But actually, 90% of the play on World of Warcraft is single-player mode. I think you might be familiar with the concept of being alone together is actually a much more common and popular way of playing games. Quick aside, this is possible to use these ZK Validium states with multiplayer. It starts looking a lot like a state channel, so that's to be seen, but more on that possibly in the future. And the thing that these games really lean themselves to are speed runs. I think speed runs are really fun. They're a huge growing culture. Being able to sort of push a game to its absolute limit, it extends the longevity of the game much past when it's released. And you'll find that you can make a speed run basically out of anything. This is somebody making speed runs out of Ableton Live recreating Cranked At by Soulja Boy. And it solves a really interesting real problem for games outside of the blockchain space as well, which is proving that the game was actually played. If you've ever seen the movie King of Kong, Fistful of Quarters, it's one of the most dramatic sports narratives ever, but it's all about Donkey Kong competitive players. There's the most amazing evil villain who might be cheating. And these pictures are all from Minecraft recently when there was somebody who had an unbelievable speed run, but it was found out to be fake. Creating a cryptographic proof that the game was played according to the rules of the game solves that problem. And it's what we've picked up over at Trifle. I'm going to talk quickly about how we've applied it. We began with sort of the earliest video game concept of asteroids and took it a step further to think, what does on-chain physics look like? Here's a model of the three-body problem. So these bodies have physics. They have gravity that are changing and determining where they move. It's chaotic, but it's deterministic. In order to make things sort of deliverable to consumers, we like to think that it needs to be provable on their client machine. We can't be dependent on a third-party prover network, which means that there has to be basically under 1 million constraints, under 1 million pieces of logic inside of the code, which for a simulation like this means that you can create the proof in under a minute. And it's about 20 seconds at 25 frames per second in order to create this proof. Now, very quickly, we realized that actually shooting these things is really fun. And so adding a bit more complexity, keeping it under 1 million constraints, under 1 gigabyte prover file too. This is the sort of large file that a user has to download in order to create the proof to their browser. Still a minute, but now 26 seconds. And now taking this a whole phase further, we land at anybody problem. So this is the game we released last Friday. Every level has 1 to 10 proofs that get generated in between 1 and 10 seconds. There's 5 levels every day. The logic runs at 25 frames per second, which if you want to put that into other dubious statistics is basically 22,000 transactions per second on base. The visuals run even faster than that, and they're all using client-side proofs, so you're no longer dependent on some new prover network which is untested. We do use a prover network as a fallback, though, because phones are really slow and people on older hardware have trouble generating that fast. So shout out to Sendry, who's doing a great job of that. Batching all these into a single TX, they are around 20 cents per game. As I said, we launched last Friday, August 16th, but we're coming to other EVMs soon. We're Trifle. Say hello if any of this makes you happy or if any of this makes you really mad. That is my talk. Thank you very much.